That's a pygmy seahorse from Indonesia. And anybody know what that one is? It's a frogfish. Kind of hard to see the fish though, right? So let's see. Here is the eye. Those are the pectoral fins. That's the mouth. And its dorsal fin has been transformed into a fishing rod, essentially. So there's the dorsal fin. It goes up there and attaches this little appendage. And they sit very still on the reef, waiting for something to come eat that lure, and then they grab them. They look very much like sponge on a reef, so they're very hard to see. How about this one? Anybody know what this is? It is a Greenland shark. They live in the high northern latitudes. And one of the things I should say is that one of the things scientists have discovered is that even in the most extreme environments, we've discovered that not only is life there, but it flourishes. And that you could say that with the Greenland sharks. So they live in high northern latitudes. During the summer, they're very deep in the ocean. During the winter, they'll actually come up to the ice edge. We don't know a lot about them, but we think that they can get to be like 20 feet long. They might live to be 200 years old. We think they have a very slow metabolism. But when the few that they've caught and they've looked at the stomach contents, they've found other sharks, they found halibut, they found seabirds, they found a reindeer and a dog. So there's this real question of, if they're these slow zombie-like sharks, how are they eating all these things? And all I can picture in my head is, during the winter, there's some poor dog or reindeer who's like at the ice edge doing one of these, and the shark. But we don't really understand how they feed. One thought is, many of the Greenland sharks have a copepod, a parasitic copepod that hangs off its eye. And people think that it just sits there and uses that as a lure. And something might swim in and go to eat it. I don't know. This has to be my favorite common name ever. Bone-eating zombie snot worms. Who came up with that? That's so great. These were just discovered in something like 2004, 2005 in Monterey Bay Canyon. They are tube worms that live on dead whale bones. And so here's a colony of these worms living on a dead whale bone. This is the worm itself, and its roots kind of look like this bile green color, are jam-packed with bacteria. And that bacteria can digest the fat and oil from the bones. And so, can you imagine who might be looking at this in biotechnology? The best next super detergent. They're looking at the bacteria since they digest fat and oil to create the next super detergent. That's kind of interesting. Okay, so I also have to say why they're called snot worms, because if they're disturbed, of course, what do they release? Mucus. So my whole goal with this book was to get people to realize that no matter how big, slow, small, or bizarre an animal is, it's not only important to the ocean ecosystem, but to human society as well. And in other words, they all matter. But of course, the diversity of life in the sea and species across the world are at risk. Because who is the ocean's most fearsome predator ever? Us, exactly. Now, I do a lot of work with the media, and typically somebody says to me, what is the worst problem in the ocean? But I don't really like to give just one problem, because it really depends on where you are, what you're talking about. So I like to give my top 5. So we're going to play a little game we'll play a little family feud, the 5 top pressing ocean problems, and I'm going to have you tell me instead of me tell you. So what do you think my top 5 problems are? Plastics. Okay, plastics is part of pollution. I don't have the ding, 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 ding. Yes, plastics is one. What else? Acidification, which is part of what? It's part of climate change, right. So those of you who may not be familiar with this term for acidification in the ocean, as more carbon dioxide is released into the atmosphere, more is being absorbed in the ocean. And it's changing the pH of the ocean. It's making it more acidic. And this is very bad for organisms that create shells or skeletons of calcium carbonate. And it also affects biological processes. So we've got pollution and climate change. So warming of seawater also. So pollution, climate change. 3 more.
Chemicals like DDT.
Chemicals, you're right, but that's part of pollution. We're going to put all of that into pollution. Other things?
Overfishing.
Overfishing, thank you very much. Yes, another ding, 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 yes. Overfishing. 2 more. You want some hints? Lionfish.
Invasive species.
Invasive species, thank you. So we've got pollution, overfishing, climate change, invasive species, one more. Loss of habitats, thank you. Loss of critical habitats like coral reefs, mangroves, wetlands, the things that really are important for nurseries, the protection of the shoreline. So my top 5 are climate change, pollution, overfishing, invasive species, and loss of critical habitats. And these are really putting not just the ocean at risk, but everything that lives in the ocean, so species. But I don't want to just mention the problems without saying, well, how do we fix it? There's no one answer, but there are a lot of things that we can do. Things like creating marine reserves, actual no-take marine reserves, improved aquaculture. You know, overfishing, we need to feed people, and I think there's going to be 2 things. We're going to find that there are some species we can't commercially fish in a managed way. Some we probably can. And then we need to find sustainable aquaculture, to grow fish in an environmentally friendly way. We need to prevent, one of the latest things that's been going on is, you may have seen some policy come out about illegal fishing. Turns out that illegal fishing is also associated with the drug trade and slavery. So there's been a big push recently to try and combat illegal fishing. I personally have been very involved with trying to cultivate high-level champions and investment in education outreach and research. I think one of the things we have not done well enough is invest in outreach and education, and being here and seeing all of you here and what this center, the Refuge, does, this is exactly what we need to invest in, to educate our kids all the way up to adults. As individuals, a lot of times people say, well, what can I do? I'm just, just an individual, just one person. Every individual can make a difference. A couple of things. As a consumer and as a voter, you have great power. So what you choose to eat, I would encourage you. There are a lot of great organizations. There's Monterey Bay Aquarium, the Safina Center. They put out guides on sustainable seafood. I will look into that. Please, I think Sanibel, you guys are probably very good at this, but obviously disposing of your trash properly and recycling, and also voting for our leaders that take the oceans and coasts seriously. Here in Florida, we have a huge problem. Our political leaders are not protecting our coasts and oceans. They're not. And I sit on something called the Florida Ocean Alliance. I sit on the board, and one of our goals is to get the state government to pay more attention to the ocean and coast. And I actually feel it's embarrassing how little we're doing. But as voters, you can play a role in that. You can write to your congressman, you can write to your state legislators and let them know that the ocean and coast are important. So in addition to my Sex, Drugs, and Sea Slime book, I've written a few others. As I said, I've discovered completely unexpectedly this real joy in writing, especially in making science fun and entertaining and understandable for all ages. And a few years ago, I was giving a talk like this, and somebody said, oh, look, you have children's illustrated books, and that tends to be for 4 to 7 years old, and you have popular science, which is high school and above. What about the middle graders? What about the 8 to 12 years old? And I started thinking about it. And they're right, I hadn't targeted 8 to 12 years old. That's a really important age. At that age, you're being strongly influenced to what your career is going to be. Maybe not your career, but what your hobbies or lifelong interests are going to be. You have huge influence not only over your peers, but your parents, right? And those middle graders are our future leaders, whether it's science, politics, innovation. We need to be hitting that age, and I was not doing it. So I did my homework, and I also had a lot of educators say to me that there wasn't a lot of science or ocean in the books that are out there. And I will tell you, there are fantastic books out there for middle graders. Anybody here or your kids, did any of your kids read the Percy Jackson series? Did they like that, right? Oh my gosh, I fell in love with these books. The author combines Greek mythology with adventure and really sarcastic humor. And it opened my eyes that you could do that, for the middle grade. So what I thought is, maybe I could do that. And so I came up with a series called Tristram Hunt, the Sea Guardians. And the first book came out 2 years ago, The Shark Whisperer. Second book came out 2015, The Shark Rider. And they combine adventure, sarcastic humor, which you can probably see is kind of what I like the best. Of course, you have to have a good villain. In the first book, the villain is shark finning and blowing up coral reefs. So there are also real-world issues. There's tons of sea creatures in the book. And there's a lot of hidden science. And in the back of every book, I have a note about what's real and what's fiction. And I've been having so much fun with these books. The target age is 8 to 12 years old. The third book in the series comes out in May. I just sent my publisher the final proofs for the book. I think it's the best of the series so far. They're just getting better. And the premise is that stingrays go missing from Stingray City. Anybody here been to Stingray City? I love Stingray City. And I get some of the best notes from kids. So this is a note I got from a kid. Dear Dr. Prager, my name is Nicholas Challenger. Is it okay for me to play Tristram Hunt in the movie? My other favorite books are Harry Potter, and I have a pet fish to play a fish. I mean, it's hard to beat that, right, with kids. Here's just a couple pictures. Look at the grin on this girl's face. This has been one of the most rewarding projects I've ever done. And here's a group of struggling reader, a summer reader program, struggling readers. I purposely made these books easy, fun, fast to read, but you're getting not just the fiction, you're also getting the science. And so it's just been terrific. And finally, one of the things I've done when the other books in this series have come out is I've done some underwater readings. And this is one I did at the Florida Aquarium, so I'm in their big shark tank. That's me. I'm holding up, I laminated a couple pages so I could read to the kids, which are, this picture's taken from the viewing window, so the kids are outside. And so it was so funny. I knew that the sand tiger shark was over my head, and I said to the kids, I said, so, is there something? Is there something? And they go, shark! There's a shark over your head! So this was so much fun, and the kids were like, how come the shark's not eating you? And I just said, I taste really bad. I did another one like this at the Georgia Aquarium. Has anybody here been to the Georgia Aquarium? And they have whale sharks, right? I did the reading like this, the whale shark, and one of the whale sharks swam over me, dove down, and its tail bonked me on the head. And the safety diver, oh my God, he thought he had killed me. And I hardly felt it. I just kept reading. The safety diver came around and grabbed me and said, are you okay? I'm like, oh, I'm fine. But I thought about it. There were people filming. I should have pretend to be knocked out. It would have been the best viral video ever. Marine scientist knocked out on the head by a whale shark, passes out. Darn, I could have done well. So with that, I will open the floor to questions. Yes. Sorry about that.
When it comes to overfishing, what are the biggest, I don't know, 1 or 2 or 3 countries or issues involved?
So, overfishing. The biggest countries or fish?
Well,
both?
yeah.
Okay, so bluefin tuna is one. Bluefin tuna is one that we know is horribly overfished, and Japan. We have huge issues with Japan. There is also a lot of problems with, like in the Philippines and Indonesia, and but the Chinese and the Japan are probably the worst. They also have big trawlers that are industry trawlers, and they go around the world, and a lot of them are fishing illegally. And that's part of the problem, is that a lot of the fish that are horribly overfished, it's not necessarily because it's not being managed, it's also because there's a lot of illegal fishing. Tuna, obviously there's a problem with sharks. And shark, it's not just the meat, a lot of it is the fins. And I would say there's been a lot of progress in educating people about not killing sharks for their fins. So we're making headway on that. You're not going to like this, but I'm going to say it anyways. One of the fish that I don't like to eat is grouper, because it is very overfished. And I know I'm sad to say that because it tastes great, but they're very overfished, and they've actually fished their reproduction areas where they aggregate to reproduce. And imagine if you fish that, you're just cutting off the population. So grouper is an issue. So on the positive side, I always like to go positive. On the positive side, I feel pretty confident that mahi-mahi is pretty well managed and sustainable. I would say wild salmon is very well managed. So there are squid, calamari. I think squid is a very fast reproducing in a lot. So squid is something I eat. But again, you can go to Monterey Bay Aquarium, the Safina Center. You can look it up. There's plenty of seafood guides. But I think probably Japan and China are our biggest issues. There's also issues with fishing where a friend of mine and a colleague wrote this great book called, I think, The American Catch, where he talks about a lot of the fish we eat, even if we catch in the US, it's exported for processing, and then it's shipped back into the US. And that's just ridiculous. And so there's a huge problem with how we eat the fish. Where's it coming from? I mean, because we don't have the processing plants here in the US. And that's just ridiculous. We should not be exporting our fish and then re-importing it. That's crazy. Other questions?
Yeah, what's the status of microbial census that's going on to try to characterize and identify the microbes in the
So,
ocean?
the microbes.
I think was
I guess I'm not, I mean, the census of, I mean, there's a lot of work right now going on the microbes in the ocean, trying to understand what's there,
Right.
what the role is, and, you know, that's kind of we're on the forefront of that, because one of the places that scientists are really working hard to improve on is sensor technology. So studying microbes, you can imagine, really tiny things, is very hard in the ocean, and I'll give you an example. So a lot of times we use optical sensors that things pass by it, and you look at the changes in the light, but the problem is things like to glom on to sensors, and so the optics get fouled, what we call fouled, very easily. So sensor technology is something that is really on the forefront right now and will help a lot. What I will say about the microbes is that we're really beginning to learn how important they are. From corals and coral reefs to even below the seabed, we're finding microbes live everywhere. And they're much more important than we ever thought. Yes?
Been told often that fish farming is really dangerous to our health.
That's a good question. Fish farming, the question, okay. So fish farming is a balanced issue. Two things I'll say. One is that right now, the people doing aquaculture are trying to get better and better because there's a couple problems. One, you don't want to destroy coastal habitats for fish farms. You don't want to release waste from the fish farms into the coastal waters. That can be very detrimental. You don't want to free those fish. And there's a whole issue of antibiotics and what they're feeding the fish. If you're feeding the fish, it doesn't really make sense. So scientists are working very hard to improve those things. One of the things I just saw recently, that NOAA came out with policies for open water aquaculture. And so there's two places that I think we're going to see huge improvements in fish farming. One are closed systems, where you don't release anything into the water. And they're starting to do that with shrimp and cobia and some other fish. And in the US, there are pretty good laws about antibiotics and stuff. So fish farming in the US has come a long way. It's not perfect, but it's better. The offshore aquaculture presents a huge opportunity. The whole idea is that you have these big open pens, and the water naturally flows through them, and so you grow the fish in the pens, and then the waste naturally get washed out, and you can actually do things like grow algae or shellfish downstream using those wastes as nutrients. So that's nothing. Another really cool idea that I've seen in the Caribbean is creating fish farms where the nutrients are taken, the waste are taken from the fish, the waste, and they're used in hydroponic gardening. And so especially where you have lack of soil, you know, like in the Caribbean small islands, you could set up these family fish farms. So there are problems with fish farms, but it's getting better. And I would say, I guess this is how I look at it. I would rather eat fish from a farm more often than I would rather eat beef or something less healthy. You don't necessarily have to worry about mercury in farm fish. So it's not perfect, it's getting better, and it's still about weighing the balance of fish versus eating other things that are less healthy. So it's a tough question, a good one. I think you have a question?
Yeah, I was snorkeling in Hawaii one time, and I heard a rather loud clicking noise, and when I went down, this fish was actually going at a rock.
Uh-huh.
I don't know if it was coral or it was just a rock, but it was definitely eating.
Okay, so he's,
What was going on?
So he's asking about fish and coral reefs. You can hear this, it's like a chomping noise.
Yeah, you can actually
You hear it. So those were parrotfish. And parrotfish, actually, they feed by grazing algae off of corals, off of rock surfaces. They're so efficient. They actually have, they're named parrotfish because they actually have a beak-like jaw. And they're so efficient at that they actually scrape the coral And that's what you can hear it, and you can actually see the scars. Okay, so I'll tell you, let's see, we've time. We start early, we have time, so I'll tell you a funny parrotfish story. I can't resist. So when I was, let's see, I guess I was in between my junior and senior year in college, I got a great job. I was a safety diver for an undersea lab in St. Croix. Now, safety diver is really a euphemism for underwater slave. It was the best job. I cleaned up, I was the maid inside the habitat after missions. I brought pots of food down and they would give me like little cookies. I was the trained dolphin. It was fantastic and I learned so much, but it was a time when I was thinking, hey, I really like this marine science stuff. Maybe this is what I want to do. But I was intimidated by the idea of being a scientist. I didn't know if I really had what it takes. And then some scientists came on a mission to study parrotfish, because parrotfish are incredibly important in recycling nutrients in reefs, because they're such efficient grazers, they're also prodigious poopers. And so their poop is very important in recycling nutrients. Well, this team of scientists was trying to quantify how much they recycle nutrients. And so what they would do is at night, they would follow parrotfish around with little plastic bags. And they would collect their poop. And that's when I said, if collecting parrotfish poop is science, I can do it. See what you started. Other questions? Oh.
My question was going to be along the same line. What are the career opportunities for young people who read your books and say, gosh, I'd like to do marine science? Are there universities that specialize in that? And then two, what are the job opportunities?
Okay, so the question is about schools and career opportunities in marine science. So first I want to say, marine science and marine biology is much bigger than just swimming with whales and dolphins. We get a lot of kids coming in and say, I want to study dolphins. Huge opportunities, and it's really grown over time. So first part of your question, schools. There are quite a number of schools now that have marine science programs. And typically what I tell students is what you really want is a solid science background as an undergraduate. Biology, chemistry, computers, math. Math is very important. And then in graduate school is when you're really going to specialize. There are also semester away programs like that SEA program, Sea Education Association, where as an undergrad, if you think that's what you want to do, you can take a semester away and study intensely. So there are quite a few, and if any of you have kids or know anybody, there's a great website called The Bridge. It's run by Virginia Institute of Marine Science, or VIMS, but it's just called The Bridge, and they have tons of resources talking about all sorts of programs out there. There's also something called the National Marine Educators Association that has a great amount of information. As for jobs, my gosh, it's grown so much. When I was in school, it was like either you're going to become a researcher or a teacher. But now, look at, you've got the Refuge here. So you've got state conservation jobs, you've got NGOs, you've got policy, you've got research. There's a huge spectrum of jobs, and I think it's only going to grow. And one of the biggest areas of growth, I think, is outreach and education. Now everybody's starting to recognize that we've invested a lot in research, but we really haven't done as much in getting that science and information out to the public. So we're starting to see organizations hire outreach and education people. That's a big field. So huge number of jobs, and I think given climate change and the other problems that we're seeing now that are dramatically impacting the ocean and society, because I think what we're starting to see is that it's not just the ocean or land or climate, it's people that are being impacted. And so we're going to need more and more people to try and understand those impacts and come up with ways to mitigate them, prevent them in the future. Okay, well, thank you, and I'm going to be out signing books if you'd like some.
Absolutely, so thank you. And this is just, again, it's a testament where it really does take everybody working together. I know we have Dr. Milbrandt from SCCF, again, taking advantage, telling these young kids to apply for internships, whether it's here at Ding Darling or SCCF or Crow, and this is just on the island. So many opportunities are out there for students who are interested in conservation, the environment, and marine biology, and it takes everybody working together. There's no one person or one organization who can do it all, so it takes us all working together, and you just made it so much fun, and it just gets everybody excited no matter what age we are. So again, her book will be up front. She will be up front signing the books and answering questions. And a big thank you, I forgot to mention our sponsors for the lecture series, Hightower Financial Advisors in Fort Myers, and Mike and Terry Baldwin for sponsoring this lecture series. So again, thanks for coming. You have our list of future lectures and films on the table out there, and our Ding on the Wing, if you haven't signed up, is out front as well. So thanks again.